Chapter 4 is on functions. The definition of a function is every input value, which is usually the x's, has exactly one output value, which is the y. We're going to look at an example here. A common problem or question that you might be asked is figuring out what is a function, or how to determine if a set of numbers or a set of points is a function. So let's do this example. We have the points 3, 0, 4, 2, 5, 5, and 1, 2. One way to set it up is using a mapping. It's these two circles here. Let's say we have an x and a y. So our first point is 3, 0. So 3, the input value 3 maps to the output value 0. We have the points 4, 2. We have 5, 5. And then we have the point 1, 2. Now we already have a 2 in the output values in the y, so we actually can reuse that 2. We're going to draw an arrow from the 1 to the 2. Now in order for something to be a function, I'm going to change back to black. So in order for something to be a function here, you must have only one arrow from each number. So you couldn't have any repeats on the x's. So even though the 2 in the y bubble there has 2 arrows coming into it, that doesn't matter. It's all about the x's. Every x, every input has exactly one output. You want to think of it like a machine, where if you put an input number in, like the 3, the machine would know exactly what to put out as a 0. So you can't have any repeats there. When you're looking at a table, you would fill in all of your points. So we have the point 3, 0, 4, 2, 5, 5, and 1, 2. These are all coordinates. We know how to graph from there. So we have these coordinate points. In a table, if you're looking at it, you just want to make sure that you have no x values repeating. If you did, that would tell you it's not a function. It would still be a set of coordinate points, and that's fine, but it's not a function. But in this case, I'm looking at this x column right here. Because there's no repeats, that means every x has exactly one y, and that's the definition of a function. Now we're going to look at a graph. If we were to graph these points, we have the point 3, 0, which is right there. We have the point 4, 2. We have the point 5, 5, and 1, 2. Okay, so now that we have these graphed, we're going to look at something called the vertical line test. The vertical line test is when you have a graph, you would know that it's a function if when you draw a vertical line anywhere, the line will only pass through one point of the function. Meaning if it hits anywhere twice, the graph's not a function. So here's what I'm talking about. If you draw a vertical line anywhere on the graph, you need to make sure that it's only going to hit the graph once. So for all of these lines, it only hits each point once. There's no doubles, so that means this is a function. So in order for something to be a function on a graph, it has to pass the vertical line test. So this is how you can know when you're looking at a function. If you're given points, you can choose any one of these, mapping, a table, or a graph. Or if you're given any one of those, you are now able to tell what makes a function. So for the mapping, if there's a double arrow coming out, so for example, over to the left here, if this was your x and your y, 1, 2, this right here, this 1 would be your problem because there are 2 arrows coming out of the x bubble there. Okay, if you have a table, if you had any x values repeating, that would not be a function. And if you drew a vertical line, so let's say for example, so these are all my no's, these are not functions. let's say we had a graph, and we had the graph, let's do a line that goes like that. Okay, so if we were to draw a vertical line, that hits there and there. So that makes that not a function. So this is not a function. So in order for it to be a function, you've got to be able to draw a vertical line anywhere on the graph, and it can only hit once. There's a whole bunch of vocab that you really should read through and make sure you understand. I'm going to skip down to the bottom where it says domain and range. Domain is the set of all x values, the inputs, and range is the set of all y values, the outputs. So if I was going to write out the domain for this example here, you want to look at all of your x values. So it's a set, so you're going to do funky bracket, and then you're going to write all of the x values from, I'm looking up here again. And you're going to write them in least to greatest order. So we have a 1, we have a 3, a 4, and a 5, funky bracket. And then your range is all your y values, again, least to greatest. So you have a 0, a 2, and a 5. You do not have to write any repeats. We just want to know what numbers are covered in the outputs, the x values. So you would just list those numbers out. Okay, we're going to look at the variables. We have independent and dependent variables. You've learned this in science, in particular when you're talking about graphing. It's very applicable in math as well. The independent variable is always your x. It just functions on its own. It happens on its own. Your dependent variable is the y, and that happens as y changes. So the y value is dependent upon the x. So for example, if you have the function y equals 2x, in order to figure out y, you have to know what x is. It depends on what the x value is, whereas the x just happens. Now, in an example, let's say you were going to buy frozen yogurt and you wanted to figure out the cost of the ice cream. So we want to know what the cost is, but the cost is going to depend on what the weight of your ice cream is, how much ice cream you actually get. And so your cost would be your y, because that depends on your x. So your x, your weight, is going to be the independent variable because that just is determined. It just happens on its own. Your cost is the y. It's the dependent variable because the cost is dependent upon how much ice cream you buy. It's the weight of the ice cream. So that's where you get your y and your x, your independent and your dependent. Last thing for this chapter is evaluating functions. Evaluating functions is finding your output, which is y, when given a specific input x. And so this could be in an equation. It could also be in graphs. We're going to do an example of each. So let's say you have the function f of x, which we know f of x is the same thing as y. Oops. Okay, so that can always be replaced with y. So y equals, or f of x equals 4x plus 3. Find the value of f of 6. So this right here is saying I want to evaluate this function. I want to find the output y when x is 6. So we're going to take that 6 and we're going to drop that in wherever you see an x. Okay, so you're going to do 4 times 6 plus 3. So you're evaluating that function at x equals 6. And so we would get 4 times 6 is 24 plus 3 equals 27. So f of 6, the function evaluated at x equals 6, equals 27. And that would be your answer. So you're going to take whatever is in here and plug that in for wherever you see the x value. Okay, let's do another example. Your example is g of x, same thing, means the same thing as y, equals 2x squared minus 1. Find the value of g of x plus 1. So again, you're going to use that same process. Take this x plus 1, and you're going to drop this in where you see the x. You're going to make sure you use parentheses. So we're going to do 2 times the value of x plus 1, square that, and then subtract 1. Now, in order to multiply this out, we got to follow order of operations. So first we have to do the exponent, so we have to do this first. So if you're an arrow person or a box method person, whatever you need to do, you need to multiply it out. Whenever something is squared, that means it's multiplied by itself. So you have x plus 1 times x plus 1, and that whole thing is subtracted 1. So I'm going to do, if you do an arrow, you would go that way. If you're a box method person, you set up your box, you do your x plus 1, and then fill it all in. If you're arrows, you do your arrows. Either way, you should come out with 2 times the value of x squared plus 2x plus 1. You have a minus 1. So again, we're still going through following our order of operations. Now we have 2 times the number, so we need to do our distributive property. So I'm running out of room here. I'm going to zoom out. But we're going to get 2x squared. Then we have 2 times 2x, so we have plus 4x. We have 2 times 1, so plus 2. And then that minus 1 in the end. These guys are like terms, so when you simplify all of that, you should get 2x squared plus 4x plus 1. And so, again, that is your whole value for when, I should have written this, g of x plus 1 equals. Okay, so you take this g of x plus 1, you take that x plus 1, and plug it in exactly where your x value is. So that's evaluating functions. That's for when you're given an actual equation. Now we're going to look at what about this graph, because we know equations can be graphed, whether they're linear or quadratic, cubic, or whatever it is, whatever kind of function it is. So we have this graph here, and they're saying what is the value of f of 3. So again, that's your input, f of x, just like here. X is the input, so they want to know what is y when x is 3. So when x equals 3, y equals is what we're trying to figure out. So you're going to go over to your x equals 3. I'm going to use red so you can kind of see it here. So this is your point where x equals 3. And you're going to look at that graph and figure out what is the y value of that graph. Well, this graph happens to be going through the x-axis, so your y value is 0. When x is 3, y equals 0. Now let's say, just for an example, another question was saying, okay, well, what is f of, let's say, -1? You would go, I'm going to use yellow for this one, f of -1. So you would go over to where x is -1, and then you're going to move down until you hit where the graph is. So that hits at about -1. So f of -1 is also -1 because this hits right here at -1. Okay, so you're going to look at your x value, you're going to move over to that number, find where the graph is, go up or down to where your graph is, and figure out what the y value is. In summary, for this chapter, I'm going to zoom out here. It's really important that you know inside and out that a function is when every input x has exactly one output y. It's also very important that you know and can move back and forth between the words input and x and domain. All of those words mean the same thing, and the same thing for output, y, and range. All of those words will be used interchangeably, so you really need to know that vocab. There's a lot of words on that vocab list. You really need to spend time making sure you go through and understand each one. There's always questions on functions, what determines a function, using that mapping table graph, and then the vertical line test is really important as well. So this is an important chapter. Make sure you spend time on it and know what you're doing. Ask questions if you need help.